Chapters 1 through 9 without something and something. What did we skip? Skip 5 and 7, something, 8, something, 5 and 8. Yeah, because 8 is gas. So we skip 5 and 8. We'll come back to this eventually. Right? Let's see. Any other questions about midterm? Format? It's all multiple choice. How's that? They asked how many questions, and I said, well, I was making it out last week, and then the weekend hit. I went out of town with the PPK group. So we're out this morning. When I first finished doing it, there was like 85 questions. I said, oh, Lord, that's too many. So I'm in the process of editing it right now to try to get it down to a number that I know is manageable for you guys, right? So it'll probably be somewhere around 60, 65, something like that. That's a normal test.
Are there a lot of the calories and kcals and the food stuff on there?
I don't know. Well, I'm not going to answer questions like that. I can't answer questions like that. I can ask general questions. Like, if you want to know what's on it, then you go hack into my computer and you can see what's on it. Exactly. You've been taking them since you were in kindergarten, basically, right? So that's why I angered, because you knew better.
So are you providing charts of any kinds? Like
Periodic table,
polyatomic ions?
polyatomic ions, electronegativities, all that kind of stuff. I'll give you. If it's in a table, you generally don't have to memorize it, right? That's okay. We're all stressed out a little bit. Be all right.
Can we go over these concepts in chapter 9 about hypertonic and hypotonic?
Just read over it. It's not that tough. If it has the same concentration as an isotonic solution, nothing happens. You got to look at the concentration. Decide is the concentration greater or less than an isotonic solution. That's all you have to do. Hyper or hyper. Is it greater or less than? That's what you need to look at. There's only like one question homework about that, right?
Yeah.
So what do you think that means for the test? If one question, right? Versus dilution problems, there was like 4 or 5 of them. When I make out the midterm, who do you think makes the cut for making it to the midterm? Dilution problems or hypotonic questions? Dilution. That's how you decide what's important, right? I wanted you guys to at least see that concept. That's all you need to know. It's not a huge deal. Just look over it, okay? All right, let's get started on chapter 10. Acids and bases. Oh, and I know that some people don't like the idea of starting new material today. So here's the choice you could have had. You could have had a test today. Right? We just finished chapter 9 on last Wednesday after give you at least a week to finish digesting that, right? That's why the test is not until Wednesday. Those are 2 choices, right? You give the test today or Wednesday. We're going to give you a couple extra days to study. That's not going to happen. All right, let's start talking about acids and bases. The picture up here is of a bunch of citrus fruit, right? Anybody ever tasted citrus fruit?
Yeah.
They have 2 tastes to them, right? They're sweet normally, and they're also most all of them are somewhat sour, right? Why are they sour? They're sour because they contain acid. Acids, most acids have kind of a sour taste to them. In this case, citrus acid is present in high concentration in all of these fruits up here, lemons, limes, oranges, and therefore they all have kind of a sour taste to them. Some more sour than others. That's also why, like, if you look at lots of sour candies and stuff, they will have different acids in them because that's what makes them taste kind of sour. Well, you might want to know what an acid is if that's making you, if you're eating acids, right? Here's the first definition for an acid. We're going to have two different definitions for acids and bases. The first one is called an Arrhenius acid. Arrhenius acids, the definition for them is they produce H plus ions when dissolved in water. Remember, hydrogen, right? If you just have hydrogen, a hydrogen atom, it has one proton and one electron, right? Well, when it loses that electron, it goes, this is what you get, hydrogen ions, okay? You will often hear me refer to hydrogen ions. I will often call this protons because it's lost the electrons, so all that's left is protons, okay? So the terminology is a little bit weird. You will often hear me just, instead of saying hydrogen ions, I'll say protons, okay? So the Arrhenius definition for an acid is anything that produces hydrogen ions or protons when it is dissolved in water. And here's an example. We have hydrogen chloride gas. When you bubble that through water, it produces hydrogen ions and chloride ions. That actually is hydrochloric acid. Okay? It's the same acid that's in your stomach. All acids are electrolytes. Some are strong electrolytes, some are weak electrolytes, and we're going to talk later on about what impact that has. Most acids have a very sour taste to them, and they turn blue litmus paper red, and then they tend to corrode some metals, but not all acids react with all metals, right? Did the reactions lab? Everybody's done that with Ms. Owensby or myself, right? The reactions lab. We added 3 different metals to HCl, right? That's hydrochloric acid. What happened with magnesium? You all remember? You added magnesium, you added zinc, and you added copper.
That's the one that was messed up a little.
What happened? Magnesium reacted like crazy, didn't it? Foamed up even. What happened when you added the zinc? Did it do anything? It did a little bit of something. It bubbled, little tiny bubbles probably, right? It didn't go very fast. What happened when you added copper to the acid? Didn't do anything. Okay? So most metals react with acids, but it's not a universal truth, right? Okay? There are different reactivities depending upon the acid and the metal. Okay? There are acids that will react with copper. They dissolve copper. But then there's other elements they don't react with. Okay? And guess what? We're going to skip this whole section on naming acids. Boom, boom, boom. Now, a base for Arrhenius is anything that produces hydroxide ions in water. Okay? Hydroxide ions, you should recognize OH minus. Why should you recognize OH minus as hydroxide? Where have we seen that before? What? Huh? Where? Speak up. No, not everywhere. Where do we see OH minus before? It's a polyatomic ion, isn't it? Okay? So it's a common polyatomic ion. Okay? Bases, according to Arrhenius, produce hydroxides in water. Common one is sodium hydroxide. You see it in lab all the time. They taste bitter or chalky. They're also electrolytes, which means they ionize in water. Some of them strongly, some weak. They feel soapy and slippery. Anybody ever eaten any base? You ever eaten anything that tasted chalky? No? Tums, Tums or Pepto-Bismol, something like that, right? Did we drink any of that? Pepto-Bismol? Milk and magnesia? Tastes like chalk, right? No? Megan? No?
I usually take it down.
Because it's nasty, right?
Yes.
Yeah. Okay. And if you pour some of that Pepto-Bismol in your hand, you'll feel it's kind of slippery feeling. It's because there's a base in there. Okay? That's what makes it that way. Now, a lot of people don't understand that acids, right? Most people, you hear that word acid and you freak out, right? Oh, it's going to burn you. Okay? Turns out bases actually can give worse burns than acids sometimes because they feel kind of slippery and slimy. They stick to your skin a little bit, and they actually can burn worse than acids. Okay? As we're going to see in this chapter, just the word acid does not necessarily imply that it's extremely dangerous. Okay? Some acids are very dangerous. But there's two factors that play a role. The type of acid that you have, and also, according to chapter 9, concentration. The higher the concentration, the more dangerous it probably is. There's some acids. I just told you eat citric acid, didn't I? When you eat citrus fruit, you're eating citric acid. Is that killing you?
No.
Why not? Because it's in very low concentration. And citric acid, as we're going to see, is a weak electrolyte. It doesn't do a whole lot. Okay? You could even drink hydrochloric acid. Your stomach acid is hydrochloric acid. It's 0.1 molar.
But wouldn't it burn going down your throat?
It would burn a little bit going down. There's literally thousands and thousands of types of acids. Okay? Not all of them are harmful. Okay? The type of acid and the concentration are important. Same thing for bases. Okay? Now, you guys should be able to name these bases, right? You guys should already be able to do this. Why? There's a polyatomic ion, and these are named just like we've named them before. Okay? Sodium hydroxide, potassium hydroxide, barium hydroxide, aluminum hydroxide. You should be able to name all these without any problem. And I don't even want to talk about that.